Hey guys, welcome to AlLiN. So, welcome back. This is CYPHER, the only AI series that teaches you deep learning while time traveling through chaos. And today we're heading straight into a trap. This is episode 4, The Deep Dream, where our heroes must teach a neural net how to see to open a vault Titan built to imprison minds. Last episode, Aarav and Nisha discover Titan's vault hidden beneath the ruined city of Delhi 1577. Guru Samak's old lab was still operational, and its AI codes were humming silently beneath centuries of dust. So, welcome, explorers of the unknown. This is Cypher, a sci-fi AI series where every story teaches you how to build the future. And today we learn how machines see the world through the eyes of convolutional neural networks. Welcome to the playground. So this is Cypher episode 4, The Deep Dream Entering the World of CNNs. Here you can see the poster of this episode. Now let's move on. So to see what lies within Titan's vault, they must first teach a machine how to see RF while typing. These machines, they are not dead, Nisha. That is a biometric lock. It's trained to recognize only Titan. But if we teach a machine see like Samak did, maybe it will open. Then a console lights up with Guru Samak's holographic projection. If you are seeing this, I am gone. Titan has taken my world, but my last AI core lives on. You must train it, feed it with data, and teach it to see. Before Titan turns your mind into his weapon, you need to do this. The projection ends, the lab lights up, and the vault begins pulsing. So here is a new look of the characters you can see. So she is Nissa, and he is Guru Samak, and he is Aarav. The villain reveal of the Titan character will be done at the end of the episode. Aarav. We train a convolutional neural network, the same thing Guru used to predict the quantum fluctuations. Nisha. So it sees images like we do, layer by layer. Arav. Yes, these GPUs still work. If we can train a vision model, we might decode the wall's signature. It reacts to gestures, body movement, and maybe it needs to see who's worthy. Nisha. That means a neural network, a convolutional neural net from scratch. Convolutional neural network. So, what is CNN? A convolutional neural network is a special kind of brain we built for machine to recognize images, patterns, shapes. Instead of looking at raw pixels, it breaks the image down like how our visual cortex works. The key layers in CNN are convolutional 2D, which extracts patterns like edges and curves, max pooling, which shrinks the images and keeps essentials parts only. Next, we have the dense layer, which is the final decision making, like choosing cat or dog. Okay, so from this cat and dog, we will be doing a small collab hands-on project on cat and dog. Okay, just like how Guru Samak built Vision AI to defend its universe, we are going to build one now to unlock this vault together. So be with me. I will take you to the collab. So this is the collab notebook I've made for you guys. Let's have the hands-on today. So welcome to the official hands-on lab for Cypher episode 4, The Deep Dream. In this notebook, we will teach a machine to see using deep learning and convolutional neural networks. We will explain every single line of code, every import, every parameter, and every layer. What will you learn from this code? From this hands-on lab, you will learn what is deep learning, what is CNNs, how to build CNN step by step, train a model on real data sets, example cats versus dogs, and test and improve the performance. So, all right, soldiers, let's fire up the Samax code. So first we are going to see the data set. So we will use Kaggle's dogs versus cats data set, which you can download from Kaggle or use a smaller sample from TensorFlow's data set. If we don't have access to Kaggle, we will load a pre-built one from Keras. Also, we can. So let's begin by importing necessary libraries. So first we import TensorFlow as TF. TF is the common alias. Then we from TensorFlow.keras from models import sequential. This is used for building linear stacks of layers. Then from TensorFlow.keras.layers, we import convolutional 2D, max pooling 2D, and flatten and dense layers. These are the CNN layers that we already saw in the previous thing. Then from TensorFlow.keras.datasets, we import CYPHER10, the built-in dataset that we will be using. And then we convert labels to one hot coding by using the two categorical method from tensorflow.keras.utils. For visualization, we import matplotlib, and for numerical operations, we import numpy as NP. So here the libraries are imported successfully once we run this, as you can see here. Step one, we load and prepare the dataset. So we will use the CIFAR 10 dataset, which has around 60,000 images in 10 classes, and each image is 32 cross 32 pixels. We will classify only two classes for simplicity. So we will keep that as cats and dogs. So here you can see we are loading the CIFAR 10 dataset, and we're changing it into training dataset and testing data. We're splitting that. Okay. Then we are filtering out only three classes. We are filtering out only two classes. Sorry. One is class 3, which is cat, and one is class 5, which is dog. Okay. Then we are having the cat dog filter over here where np var y train equal to 3, which means the class 3, which is cat, and y train equal to 5, which means the class 5, which is dog. And here we are using the training set. So X train equal to X train of cat dog filter, which we have done over here. And Y train is equals to Y train cat dog filter, which we have done over here. Okay. And then we are moving to the testing part. So in testing part, again, we separate Y test differently and Y test of class 3 differently and Y test of class 2 differently. And then from that, we segregate both X test and Y test for the testing data set. Next, we convert labels. So whatever is in class 3, that is the cat class, we keep the label as 0. And whatever is in the class 5, that is the dog class, we keep it the label as 1. Then we have y train equal to 5, which means the fifth class, right? And AS type as int. So here we convert these two. So y train and y test. And here we normalize the pixel values to 0 and 1. Then we convert the labels to one hot coding where y train is equals to categorical y train and y test is equals to categorical y test. So now this we have the data set is prepared for cat versus dog. So this was the pre-processing part. Now we are building a convolutional neural network. So CNN layer-wise explanation you can see over here. Convolutional 2D layer scans the images using the filter kernel to detect features like edges, textures, and the features which are available in the images. Okay. Then max pooling 2D, it reduces the spatial size, helps with computation and overfitting. Then we have flatten, which converts the 2D features into 1D vector, and the dense, which is the fully connected layer that performs the classification. Okay. So this is about the CNN layers. Next after this, we are going to see the train, how we are going to train the model. So here you can see the code. So first we build the CNN model by using the sequential part, which I told you in the beginning of this thing. Then we have the first convolutional layer where we add 32 filters of size 3 cross 3, and we keep the activation as RLU, and we keep the input image as 32 cross 32 cross 3. So for further explanations of these things in detail, I am going to plan a series that is AI in 30 minutes. It's going to come soon. So that we are going to go from scratch from Python for AI till the generative AI and AI deployment. full class. I have 40 videos of that. I will be launching it soon. Okay. So first max pooling layer which we have there, what we are doing, we are adding the max pooling 2D layer where we're keeping the pool size as 2,2, which reduces the size from 32 cross 32 to 16 cross 16. Next, we are flattening the output by using model.addFlatten function, which converts the 3D output into 1D for the dense layers. Then we are having the fully connected layer where we are using dense, which is 64, and the activation that we're using that is RLU, which learns the non-linear combinations. Then we are having the output layer where we add the dense 2 comma with activation as softmax, because softmax gives the probability between two classes, that is cat or dog. So we have two outputs, either it's a cat or dog. Now we compile the whole model with using Adam optimizer, categorical cross entropy, and matrices accuracy, which we will be getting as the output. Here, then we print the CNN model is built and compiled. Here you can see it's printed, right? CNN model is built and compiled. And according to that, we are doing. Next step is that we're training the model. So in training the model, we're training the model according to epochs, accuracy improving and loss decreasing. Since I have just 5 epochs over here, you can see the accuracy is very less, that is around 76%, and loss is also more, that's around 0.49, right? So if I try to increase the epoch, then you can see that the accuracy also increases. Okay, so here we are using 313 we have, so we are using only till 5 epochs. Okay. Next, we are going to visualize the accuracy and loss. So let's see how the model performs over epochs. So we just had 5 epochs, so we plot the accuracy, train accuracy and validation accuracy. So here you can see how it differs, right? And predictions and evaluation. So let's now evaluate how a model performs. Okay. So we are going to use to know how a model basically performs. We are going to use confusion matrix, precision, recall, F1 score, ROC, UEC, and all, which we are going to use over here. You can see here. So so first we are having an additional import for evaluation. So what are those things? From Skyline.metrics, we are going to import confusion matrix, classification report, ROC AUC curve, confusion matrix display, and accuracy score. So here you can see predict probabilities and class. So here we predict the probabilities and here we predict the classes, right? Then we have true equal to np.arg max y test where we are using axis as 1. Then here we are using the confusion matrix, the formula for confusion matrix. There is an inbuilt function of confusion matrix which we are using over here, y true and y predict classes, and we are displaying that. Then we are using a classification report where we have y true, y predict classes and target names cat and dog. Then we have ROC UC curve you can see over here where we are not basically printing the curve, we are just taking the score of that, right? And here we have the accuracy and error rate. So here you can see that the confusion matrix you can see over here, cat and dog. So cat and dog predicted label you have over here, right? That is 0 and 1, which is cat and dog. So how much, and the true label. So in predicted label, you can see between cat and dog, you can see how it differs, right? So the precision for cat was around 0.65. The recall is around 0.83 and the 0.73 is the F1 score. And final accuracy, we get it around 70%. Macro average is 0.71, so total F1 score, everything if we take in consideration. ROC curve, we get it around 0.77. Final accuracy, we get it around 69.65, somewhere around that. And error rate is around 30.35. Okay. Now let's make predictions on the thing which we have derived, right? The ROC, accuracy score, and those things. So making predictions on test images. So first we predict the probability distribution for each test images. Y predict probs is equal to model dot predict. You can see our model dot predict x test, and we get the predicted classes like index of max probability and those things. Okay, just give me, yeah. So next, we get the actual classes, that is from one hot encoded labels. You can see over here where we use y true equal to np dot arg max. Then we show a few predictions with images like cat and dog images which we're using here, that is known as class labels. Then we plot it. So here you can see the actual, it is cat and predicted. You can see the image quality is not that good, but you can see this is a dog and this is a cat. This is also a cat. This is a dog, but it got predicted as cat, right? Even this is a dog, but it got predicted as cat. Why did this happen? Because you can see that accuracy is not that good for our model. So because of that, we are getting such things, right? So explanation of the metrics that we saw. Confusion matrix shows the actual versus the predicted categories. Ideal is all diagonal. Precision of all predicted positives, how many were correct, it shows that. Recall of all actual positives, how many did we detect, it shows that. F1 score is the harmonic mean of precision and recall, whereas ROC and AUC measures how well the model has separated the classes, like 1.0 is perfect. Then accuracy percentage of correct predictions, and error rate is the percentage of, we can say, the which is not predicted well. Okay. So now let us move on to the story part, right? I think now it's visible. So after that, so what did Nisha discover from this? That the models is accurate, the vault is unlocked, right? That's what Nisha says. And then suddenly thing appears, right? The vault glows, and but then a pulse and the screen shows neural signature is hijacked. Then Aarav says, "What? It's learning from us?" Then Guru Samak says, and he comes out from the console and says, Titan has learned to clone minds. The CNN you just trained, he mirrored it. He now sees through your eyes. Then Titan's hologram comes from the console. He says, Thank you for teaching me to see you. So that's it from the episode 4. So this is the next episode that's going to come, the episode 5, the mind echo. Right. So in episode 5, basically we're going to learn about RNNs. Okay. So what just happened here? We trained a CNN and Titan stole its signature. Now, this isn't just a vault anymore, it's a gateway into your memories, right? So to learn how signatures, how to rectify it, we fight back using memory powered neural networks, that is RNNs, to reserve the Titan's model in time. So that we will be seeing in episode 5, the mind echo decoding time with RNNs. Okay, so before that, before moving, let's see what all we learned today. So I'll just write down what all we learned today. So the things that we learned today are what CNNs are, right? We learned what CNNs are, then how they mimic human vision, how they mimic human vision. Then we learned how to build, train, and evaluate a model, right? With using the CIFAR 10 dataset, where we differentiated between cat and dogs, right? So we how to build, train, and evaluate a model. Then we learned the real world metrics like accuracy, right? And we learned about F1 score, AUC, ROC score, and confusion metrics, right? So these are the things that we. So yeah, thank you for your time. So we'll meet in the next episode. I hope the next episode will be more interesting than this. As you can see, each episode we are progressing a bit and bit. So we are seeing through, like, how from first episode till now, how the transition has happened. You guys would have noticed. So yeah, next episode will also be an hands-on episode. We will be doing signature projects using RNNs. So let's meet. Till that, have a great day. Take care of your life. Thank you.